Welcome to my channel, guys. So this particular series I am going to make full series all about mathematics for AI and ML. So all the topics I am going to cover is like one will be something related to linear algebra, and the second one will be all about linear algebra. I will be covering everything possible, mostly not research level but base level. Then it will be all about statistics. Second topic will be statistics. Then the third topic will be all about probability. We'll cover one by one. Okay, so be subscribed to this channel so that you will be updated when one videos will be updated regularly. And the fourth topic will be all about calculus. So I will teach each one of the concept, each one of the concept inside these particular topics. So be patient with me, watch these videos properly, right? So let's go one by one. So we'll be starting with, initially we'll be starting with the first topic is all about linear algebra. All those references like books or PDFs, whatever the things needed, I'll be mentioning in the description section of this YouTube video. So check out those description properly. If you need anything, you can comment it down. I'll be sending you through your, like, let's say you can go check out my social media network, where I can, if you will be asking me something, I'll be sharing you details. Maybe it will take some times, but I'll be sharing with you, right? So our first topic will be all about linear algebra. Hopefully everyone knows what is linear algebra. So linear algebra, everyone know, like it is all about mathematics, like matrix vectors, right? So we'll go step by step. The first step is like we'll be understanding the basic of linear algebra. Okay, what is the basic of linear algebra? So basic of linear algebra means, if I'm saying, the first one will come to your mind is called scalars. So what are the scalars? Scalars are nothing but just a singular numbers, right? Single numbers. So what is single numbers? If somebody will be asking you some examples, you will be saying like the single numbers which are not having, like, the single value which will be not having, with no direction, with no direction and with no direction and no dimension. Okay, so because I am writing it down, if you feel like I am little bit of slow, you can go for 1.25 or 1.5 speed on YouTube, right? But I have to say, I really like, while teaching, I really like to write it down rather than presenting them in a PPT, right? So what are the examples possible for scalars? For scalars, examples are like, let's say if you have an age, I can write it down as 21. So a variable like temperature, I can write it down as, let's say, 50 degrees Celsius. So these are the variables, or you can say, so single number of variables which is assigned with single value, right? So you can also have something like, let's say, any numbers like 2 by 7, something like 5.1, etc., right? These are all single value. So any value which is having single number is called a scalar, right? Then we'll go to something called vector. What is that called? Scalar. Then we'll have something called vector. So what are vectors, right? Scalars, we have no direction and no dimension but a single value. In vector, we'll say vector, it is a list, it is a list of numbers, the list of numbers which is can be called a 1D array. Hopefully, if you guys are from computer science background, you might have known about array, what is a 1D array, 2D array. But if you are not, don't worry, I'll be explaining everything to you properly. So what is a 1D array? So what is that I'm taking? The definition is all about, it is a list which is contents of numbers. Now I can also say a line of numbers, a line of numbers in 1D, okay, with one direction. I can say it has a direction to it, or direction to it, right? And if I will be taking some example for vectors, so let's say Ram, my name is Ram, right? Hopefully you guys know, if you know, it's, let's say, if I'm saying Ram's mark in exam, okay, Ram's mark in exam. So in all subjects, right, let's say I'm checking my marks in all subjects, and I'm checking like this, so it has something like I have to put it in a 1D array, right? So my marks are like, let's say 50, 70, 80, 90, 95. How many subjects I have? Let's say 5 subjects. I score marks like this. So it looks like a 1D array, right? It is a 1D array because it's present in single list. If you guys don't know about Python has a data type called list, where we put at like values in a ordered format, right? You can see it's an order format, like this is in position 1, position 2, position 3, position 4, position 5. But it comes to index, you can say 0th index, 1th index, to a second index, third index, 4 index, right? If you don't know about Python, go through the Python basics properly. You will be able to understand what I am talking about, right? So now if we'll go to another example, let's say another example will be something like, so this is in a 1D space, right? So if I'm saying position, if I'm saying something like this, position in 2D space, what does this mean? Position in 2D space means, let's say if I am having a list, in that list I'm saying x is equals to 5, y is equals to 7. If you are smart enough, you might be linking it with something like this. So let's say if I am having x and y axis, in this x and y axis I'm having a date point somewhere here, right? 5 and 7 somewhere here, let's say 5 and 7. If I am drawing something from the center, which is origin, right, to that particular point, and I'm having a direction towards that point, this is nothing but a vector. This is nothing but a vector. Clear? Hopefully you guys are clear. Any doubt, you can comment in this video, right? So this is what position in 2D vectors looks like. You can also have something like another example you can take. Another example you can take something like, let's say daily temperature in daily temperature in Bangalore. Let's say I'm staying in Bangalore. What is the temperature here every day? So for last 1 week, let's say 1 week temperature, last 1 week temperature, if I'm writing it down, something like 30, 29, 41, 20, 32, 3, 4, 5, 30, 28, something like that, right? This is also looks like a 1D array where I'm containing numbers, like singular numbers. Now you might have been noticing one thing, these all vectors are actually having single values, like scalar values, like this is a scalar 1, this is scalar 2, this is scalar 3, scalar 4, scalar 5, scalar 6, scalar 7, right? Because we have 7 items inside a list, I'm saying, or array, I'm saying 7 scalar values present, because those are numbers, like single numbers. Now what is this mean? The vectors are combination of scalar values. Yes, you can say that. Now most probably if you are if you completed your if you have ever read or like read like something like physics, you might have known we write vector like this, right? 2, 3, 4, something like this. This is same only. If I'm writing something like this in this format in a list, both are same. This you write in pen and paper, this you mostly gonna write in a coding format. Clear? Hopefully you guys are clear. So if you guys are clear, we'll jump into the third type. The third type is called matrix. Okay, the third type is called matrix. Now hopefully you guys know what is matrix, right? Matrix from child time, like from 10th, time we are studying about matrix, right? Matrix is nothing but matrix is combination of the similar way vector is a combination of scalars. Matrix is combination of rows and columns, mostly in 2D space, right? In 2D space we are talking about 2D. Now what is 2D? 2D is nothing but, if you have ever seen, 2D is nothing but grid like structure, right? Have you seen Excel? Right, you might have seen Excel, right? In Excel what we have lots of columns and rows, right? That is where we are talking about. In matrix we are talking about that same thing. Now I'm saying in matrix is a combination of rows and columns. Let's say instead of here we had something like Ram's marks in exam in all subject. Here I'm taking an example. The example is marks of three students in 4 subjects. So we have 4 subjects and 3 students. What does that mean? So if I'm going to represent it in a variable like this, so one guy is having one list. So how many guys I have 3 guys. That means how many lists? 3 lists. So let's make 3 lists first. Okay, let's make 3 lists first. How many lists? 3 lists. So how many subject? Each guy is in 4 subjects, right? So 80, 85, 70, 75. One guy, one list. Second guy having second list, right? 80, 85, 95. The second guy is done. Then third guy is, right? 90, 95, 75, 65. So if you will consider this, these are all vectors. Now I'm covering every vector into another list. Oh sorry, every list, all list covered with full list. Now this becomes a matrix. But if we be seeing, this one is a vector, right? This one is vector 1, this one is vector 2, this one is vector 3. So your M, which is a matrix, is something like this: vector 1, vector 2, vector 3. Now if somebody will be asking you, vector are combination of scalars, now matrix are combination of vectors, there is a link to it, right? But most important part is, if somebody will be asking you what is this row numbers and column numbers, we are saying 3 student 4 subject, this is a 3 cos 4 matrix. Yes or no? You can see 3 rows 4 columns. Clear? Hopefully you guys are clear. Now if somebody will be asking you, हम लोग जैसे फिजिक्स में लिखते थे ना, राइट? in physics we used to write like this, right? So this will be written as 80, 85, 70, 75, 70, 80, 85, 95, 90, 95, 75, 65. Sorry, I told wrongly. It's in mathematics, right? So this is what a matrix when we write in hand looks like. This is what how you are mostly going to write in a coding format, right? So we studied about 3 things. Scalars is nothing but single values, single numbers. Vectors are combination of scalars which is having some direction to it, right? We saw in an example in a 2D space. In a 2D space we took a point and figured it out how the direction matters, right? When it comes to matrix is a combination of rows and columns in a 2D space, and it looks like a grid, and these are the examples. So if you guys clear, we'll jump into the harder part. The harder part is called, the last part is called tensor. You might have heard about this word tensor mostly, but if you don't, it's okay, I'll be explaining it to you. So what is tensor means? Tensor is it's a multi-dimensional array. That means what? That means more than 2D, 2 dimension space. So me, it can be 3D, 4D, or any number of dimension, that is ND. Clear? So if somebody will be asking you what is an example of multidimensional array, it's pretty clear. So now see this how I'm writing it down. So if somebody will say colored image, right? We all know what is colored image. So what is colored image? So colored image is having 3D structure, right? Colored image is having 3D structure. How? In color image we have something like height, width. This we all know, right? There is something also called RGB. Remember RGB? Red, green, blue, right? Now how we are going to represent it actually mostly? So let's say if I am having a shape, the shape is written it as like this, like 110, 110 and 3, right? It means actually, it actually means 110 pixels and 3 color channels. Clear? Hopefully you guys are clear how we are representing it right now. So when we represented a matrix, the matrix time we represented like this: 5, x equals to 5, y equals to 7. That means we are mostly saying 5, 7. This is row, this is column. Now in this case we are saying height, width, and there is a RBG, but this is particularly for images. Okay, so let's say if we are saying something like this is something for images. If you are saying something like for let's say video data. Okay, for video data. Now in video data we will have something called frames and height and width, and there is also channels. Channels means color channels. I'm talking about color channels. So how many there are? It looks like a 4D, right? This is 3D, right? 3D structure. This is 4D structure. So if you will be looking into closely, then you will be understanding what is the definition of greater than 2 dimension or multi-dimension array. Okay, so tensor is a multi-dimensional array. Now how we are going to, in a real world time, how we are going to explain it? So let's say I'm taking an example. In that example I'm saying there is one box. In that box it has its length is equals to 5, its width is equals to 4, its depth is equals to 2. Then it can be simply write like, okay, then write like, we can write it like 5, 4, 2. Yes or no? But there is a catch here. But in tensor it's like, but in tensor it's actually like 2 depth, okay, each with 5 rows and 4 columns. Guys, sorry, there is a rain going on. If you guys are like hearing some sound, which I don't think, because this microphone is having condenser, but if you are still able to hear it, sorry for that. So 2 depth, 5 rows, 4 columns. So if I want to represent it in certain way, so I will be writing tension variable is equals to, let's say 2 depth, right? So I'm randomly, these numbers are actually random. Okay, so I'm writing, look at this, 5 rows, 4 columns, right? Look carefully how I am writing. 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5 6 7 8 9 10 11 12 13 14 15 16. How many rows are there? 1 2 3 4. Then another row, right? 17 18 19 20. This becomes your one matrix, and this matrix is called how much? 5 cross 4 matrix, 5 cross 4 columns. Then look carefully, again you have to write, look closely. Again you start with another matrix. That matrix is having 5 rows again: 21 22 23 24, comma 25 26 27 28, comma 29 30 31 32, comma 33 33 34 35 36. These are random numbers. Again I am telling, don't be confused yourself, how I am getting these numbers. So 37 38 39 40. So see this, now this becomes 1 2 3 4 5. Close that even matrix. Now this matrix is having another matrix which is a 5 cross 5 5 cross 5 4 matrix. So all these two matrix getting closed with another matrix, the bigger one. Clear? Hopefully you guys are clear now. So this matrix is having, the first matrix is called depth of 1. The second matrix is called depth 2. So you can see when I wrote what is the meaning of 5 4 2, this is 2 depth, 5 rows is 4 columns. That means each matrix is having 5 rows 4 columns, and total tensor depth, this is T means tensor, right? The tensor I am talking about, it is having depth of 2. Hopefully you guys are clear about what is tensor, what is matrix, what is vector, what is something called like scalar. If you guys clear, I'll stopping it. We'll go to next step, indexing and slicing. Thank you guys.